So on to Chapter 8 of MYP4 Unit 2, and it's all about inequalities. So you're familiar with simple inequality problems. So 3x plus 2 greater than or equal to 14. So just treat them like equations. Take away 2 from each side to get 3x greater than or equal to 12. And then divide by 3 to do x greater than or equal to 4. So the answer is that x is any value greater than or equal to 4, and you can represent that solution on a number line with x being any number 4 onwards, and to indicate the fact that x is allowed to equal 4 as well as being greater than 4, then you fill in the circle on the number line. So that's all from a previous unit. And here's another one. Solve 3x minus 4 is less than x plus 1 and express the solution on a number line. So here I've started with 3x minus 4 equals x plus 1. I've taken away 3x from both sides to get minus 4 is less than 5x plus 1. I've taken away 1 from both sides to get minus 5 is less than 5x. And I've divided both sides by 5 to get minus 1 is less than x. So minus 1 is less than x, or looking at that the other way around, x is greater than minus 1. So x is any value greater than minus 1. And I've represented that on a number line with a pretty badly drawn number line here of x being any number from minus 1 onwards. And importantly, I've not filled the circle in this time because x is a greater than value than minus 1, but not a greater than or equal to. So because x is not allowed to exactly equal minus 1, then it's not filled in. And again, that's just revision from a previous unit. Now just remember there to be careful with minuses. You can't multiply inequalities by minus 1. So to illustrate why that's the case, 3 is less than 4, but minus 3 is not less than minus 4. So inequalities can also involve quadratic expressions. That was the new information for this unit. So for example, x squared plus 3x plus 2 greater than or equal to 0. Now, in fact, the left-hand side of that factorizes nicely into x plus 1 times x plus 2. So go back to Unit 1 and just revise factorization if you can't remember how to do that. So x plus 1 times x plus 2 is greater than or equal to 0. Now, there's two ways that can be a number that's more than 0. It can be if you get two brackets that are positive, so you get a plus times a plus being a plus, or in fact if both of those brackets are negative numbers, so that you get a minus times a minus, which gives you a plus. So those two brackets will only have a product greater than 0 if they're both plus or they're both minus. So the question is, what values, it's very hard to read, isn't it? What values of x will make that's got slightly sabotaged, I think, whatever I wrote on the board at the time. But that's supposed to say, what values of x will make the whole expression greater than or equal to 0? So both brackets of x plus 1 times x plus 2 will be positive or 0 as long as x is greater than or equal to minus 1, because then you get the first one being 0 and the second one being something more than 0. Both brackets will be negative or 0 if x is less than minus 2, because then you get the first one being negative and then the first one being 0 or negative. So the whole thing will be greater than 0 or equal to 0 as long as x is greater than or equal to minus 1 or less than or equal to minus 2. So it's whatever value will make both brackets positive, or whatever values will make both brackets negative. So we can represent that on a number line, a fairly badly drawn number line, I have to say, saying that as long as x is less than or equal to -2, or greater than or equal to -1, then you'll either get both brackets negative or 0, or both brackets positive or 0, making the whole thing positive or 0. And then I've written this concurs with what we observe if we plot the graph of y equals x squared plus 3x plus 2. If we plot that graph on GeoGebra, say, then we get that curve that just dips below the axis, the x-axis, between -1 and -2. So the whole function is above the x-axis as long as the x value is greater than -1 or less than -2. So I've written the function is greater than 0 as long as x is greater than -1 or less than, that's supposed to say -2 there, so a little glitch there. But if x is between -2 and -1, that should say there, then the function is negative. I think that's a little board glitch rather than me having written the wrong thing at the time. So that should say a -2 there and a -1 there. So we did some questions in class. Solve the following inequalities and express the solutions on a number line. 4 questions there. So have a go at those, pause the screen, and have a go if you haven't done them yet. Here's answer 1. So I hope you pause the screen. So x squared plus 2x minus 8 is greater than 0. That factorizes into x plus 4 times x minus 2 greater than 0. So if x is greater than or equal to 2, then both the brackets will be positive or 0. But if x is less than or equal to -4, then both the brackets will be negative or 0. So on the number line, that's the solution there, with x being either greater than or equal to 2 or less than or equal to -4, making the whole thing come to something that's greater than 0. Question 2, x squared minus 4x plus 3 greater than 0. So that's a greater than rather than a greater than or equal to. That factorizes into x minus 3 times x minus 1. So both the brackets will be positive if x is greater than 3. Both the brackets will be negative if x is less than 1. So the solution is that x has to be greater than 3 or less than 1 to make both brackets either positive or both brackets negative, so that when you multiply them together you get a number that is positive. So there we are, x less than 1 or greater than 3 on the number line. And I haven't filled in the circles because x isn't allowed to exactly equal 1 or 3, because the whole thing has to be greater than 0 rather than greater than or equal to 0. And here's question 3. Now this one's a bit tricky because we've got x squared plus 2x minus 48 is less than or equal to 0. So the whole thing has to come out to be a negative number or 0. So when you're multiplying two numbers together, if you want the answer to be negative, you've got to have one of them being positive and one of them being negative. So we either need the first bracket to be negative and the second one positive, or the other way around if we can. So thinking about the possible values for this, if x is anything less than 8, or minus 8 rather, if x is anything less than -8, then both brackets will be minus numbers. If x is anything more than 6, then both of these brackets will be positive numbers. So the way to get one of them being a positive number and one of them being a negative number is all of the values in between those two. So if x is between -8 and 6, let's say if x is 2, for example, then you'd get one bracket being a negative number, 2 minus 6 will be -4, and you'd get one bracket being a positive number, 2 plus 8 is 10. So as long as x is between -8 and 6, then you'll get one bracket positive and one bracket negative, making the whole thing, when you multiply it together, a negative number. Here's the last one. X squared plus 3x is less than or equal to 10. Well, all I've done with this one is take away the 10 from both sides. X squared plus 3x minus 10 is less than or equal to 0. So that I get your standard sort of looking quadratic where you've got something with x squareds and x's and a number equals 0. And as it happens, well, not by chance, but by design, that factorizes nicely into x plus 5 times x plus 2 is less than 0. And to make the whole thing less than 0, so to make the whole thing negative, we need one positive and one negative bracket multiplied together. So we'll get one positive and one negative bracket if x is anything between -5 and 2. So for example, if x was, let's say, 1, if x was 1, then you'd get x plus 5, 1 plus 5 is 6, and 1 minus 2 is -1. So as long as anything in that range, as long as x is anything in that range, then you get a positive and a negative bracket, meaning that when you multiply them together, you get a negative number. So there it is on the number line. X is allowed to be anything between -5 and 2. And because this is an or equal to inequality, then it's allowed to take the values on the boundary. The whole thing is allowed to be 0. So x is allowed to be the values on the boundary, -5 and 2, so the circle is filled in.